Thanks. So basically, we decided to prepare a number of baselines this year, and this is the one that, in this case, it was done with Sergio Oramas, who is now our ex-music technology group member. Now he's working at Pandora. The idea of this baseline was that we just wanted to explore the idea of combining different genre datasets, these different information about genres together, if that can improve the results or not. So we didn't care much about the, let's say, the having the best classifier possible, but the idea was kind of combining various weak learners. If we can combining those from different datasets, if we can improve something. And basically, that we used all the features that are provided in the task, and they have some categorical features as well, like, for example, key, musical key, or scale, major or minor. Those were obviously recoded, so they were one-hot encoded. Then we did some typical standardization, and well, basically we have approximately 2,700 features to work with. And this is the same features that the guys that did the best submission last year they had. So for the first task is basically given one data set, train a model that can predict genre within the taxonomy of that data set. And in this case, we used, as an example, a basic neural network, only one hidden layer. So we have one layer, like the input layer, which is song feature vector, which was 2,700 approximately size. Then we have the hidden layer, fully connected, which has the dimensionality 256, and then that is connected to the output layer, which is the number of classes in the target data set. So it would be, for example, 700 approximately for all music, or 400 for Discogs. So basically, you can't do it more simple than that. So it's actually not working very well, okay? So now the idea was that if we train that, so we end up with a feature embedding. So we can do that on all 4 datasets that we have. All music, Discogs, Last.fm, and Tag.tram. So we end up with those feature embeddings. And now the idea is that we actually can use those as features and then train another model for each dataset that will use all 4 embeddings to predict the genre within the taxonomy of the target dataset. So basically, this is just what I said. So basically, we call that like a fusion network, and we use them all stacked together, and it works. So what we saw is, for example, checking this is on the validation dataset that we have. So subtask 2 is when you can use altogether all datasets, and subtask 1 is when you can only use the one dataset. So for all datasets, we improve on, for example, ROC AUC value. And for example, we tried with Discogs. So this is that score using only data from Discogs, and then adding all music, the embedding from all music we improve, and then adding the embedding from Last.fm we improve a bit more, but less, and then adding the last dataset we improve even more, but even less amount. So this actually works, and the actual predictions of the network gives the activations, and basically you need to decide to threshold the activations to say if there is a genre or not. And basically this is the plugin rule approach, where we have individual threshold for every genre label. So we decided to maximize the macro F-score. So this is per label averaged F-score. And then you just find the best threshold to maximize that F-score. There is a problem with that, though. So what we got is that basically maximizing it, if you have a very infrequent label and your classifier is really bad, then the best strategy is just to always predict that label. So this, for example, we always predicted in the task 1 that all music in the world that was given as an input is New Age meditation, stuff like that. So our task 1 classifiers were really weak, but when we transferred to fusion models, we improved in all metrics, except for a few cases for recall. And the conclusion is basically combining all together all datasets, we can improve performance. The good thing about the early fusion that we did is that we don't need to learn mapping what genre in dataset A means in dataset B, so we just we don't think about that. And I think that we can replace our very basic example network with something much more complex. And this could be either the approach that Henrik will present now or the best approach from last year, and test again this idea. So hopefully combining the embeddings learned with those more complex architectures will be even better. I think I want to highlight one thing here, that we didn't know what to optimize, because in our task we didn't suggest explicitly what is the final goal. So there's micro F score, there is macro F score. What do you want? So in this case we go for macro. Okay, but then optimizing that worsens your per track F score. So this may be something to think about in the design of this task. And yeah, we ignored the genre hierarchy, as Julian mentioned, just because we found that some genres are too broad, and our activation in the network may be predicting that very low confidence for that broad genre is there, but for some subgenre of that genre, it may be very high. So we didn't want to risk. We tried to do that expansion, and it didn't work for us. So that was kind of the conclusion. So we'll present that on ISMIR. So this is the plan now that I just mentioned. Try different models with this approach. And also one interesting thing, that maybe adding different data sets, you actually have different results. So maybe adding one particular data set gives you better improvement than another one. What's the reason for that? Is that just the size of the data sets? Is that their taxonomy? Is that something specific about those data sets that makes them useful or not? And I think we can play around that actually to understand which, let's say, genre taxonomies are useful that you can reuse, which aren't.